on, settle down. Hey guys. Okay, so let's flip our question around. Okay, so we left off where I said, if x is this value, how much is to the left? What if I flip this around and I said, to the left I have this much value, where did I draw my x? Okay, can we do that?
I think so.
All right. I think you can too.
I think you do.
Okay, so let's say this time I said I draw a line right here, and let's say the area I get to the left is 9099. Okay, where did I draw my x? The area I have to the left is 9099. Okay, so yeah, don't, well, I guess, yeah, okay, go ahead. If you found it, call it out.
1.34.
X equals 1.34. Great. Okay, so if I have 0.9099 to the left, I drew my x at 1.34. What if I said I've got 0.20? Oh, not, this is the wrong spot. Let's say the area over here is 0.20. Where did I draw my x? Okay, so don't shout it out just yet. So find where I would draw my x in order to get 20% to the left. Yeah, it won't be exact. It won't be exact. You're right. Okay, so what's the closest number you could find?
0.20.
I'm getting x is at negative 0.84.
Can you explain it?
Okay. If I drew a line at x equals negative 0.84, the area that I would get to the left isn't exactly 0.20, but pretty darn close. 0.2005. Is that okay?
Is that because it's the number that has most zeros?
No, it's just the number that's closest to 0.20. Okay.
Gotcha.
So this, again, x is actually a continuous variable, right? So it takes on all these numbers with extreme precision. We only go out to 2 decimal places, and that's why you don't have every single value. But it would, again, it would be impossible to write off every single value. Yes.
Is there a specific way to find out without having to fish through the entire chart?
You got to fish through the entire chart, okay? But all the numbers are in order. The numbers are in order, okay? Right? They start close to 0. They go all the way up to 0.5 on this side of the table, and on this side they start at 0.5 and they go all the way up to 1. You've got to fish through the entire table, but it's not too bad because they're all in order.
Yes, that's true.
Okay? All right, one more. Let's just make sure we've got this. All right? What if I draw a line and I'm at, I keep putting the number down here. I want to know, where did I draw my x if I get 0.35 in this area? Okay? Pick the closest number. Pick the closest number. Okay, don't shout it out. Just write a number down on your paper. Okay, you'll be faced with a decision. Just pick the one that's closer. Do you have a question or you have the answer? Okay, great. We're going to give everybody else an opportunity to find the answer also. Okay, did everyone get it? Okay, where should we draw the line if we want 35% to the left?
Negative 0.39.
Yeah, negative 0.39. Okay? Also acceptable is negative 0.38,
Right.
but negative 0.39 is closer. We'll give me a value that's closer to 0.35. Okay? Yes?
So if, for example, that showed up on the test and it was either 0.39 or 0.38, would you mark this down if it was 0.38? Or would you also accept
Well, okay, so it's multiple choice, right?
Right.
So I pick an answer, okay? I will put, if this question appeared, I would put negative 0.39. I will not put negative 0.39 and negative 0.38, okay? I will not put both of those down. So, so pick the one that's close. If you pick one and the other one is off by, and the one you don't see your exact one, but one that's like off by 0.01, then that's probably the answer, okay? Yes, question. How did I get negative 0.39? So remember, I'm looking for the x, for where I should draw my vertical line so that the area that it gives me is 0.35. So essentially, in the entire table, there's a whole bunch of numbers to look through, but in the entire table, I'm looking for the number that's closest to 0.35 or the number that's closest to 0.3500. Okay? In the table, what I see is 0.3483 and 0.3520. 3483 and 0.3520. Can you find that in the table? It's going to be on the negative side, and it's going to be kind of in this lower right-hand corner. The normal table. Okay, you found that? Okay. Those numbers correspond to negative 0.38 and negative 0.39. Do we see that?
Mm-hmm.
I know you guys do, but I want to make sure these guys do. Do we see that? Do we see that those numbers correspond to negative 0.38 and negative 0.39? Okay, so that's how I got it, okay? And so between these two numbers, this number is closer, and this number corresponds to negative 0.39. So that's how I got negative 0.39. Okay, so this is great and all, but we're not always going to be dealing in a situation where the mean is 0 and the standard deviation is 1. Okay. When we took our first quiz, I had a problem asking about z-scores. You guys remember that?
Yes.
And what was it? It was about like tigers or something?
Right.
Yeah, Bengal tigers and Indo-Chinese tigers or something.
Right.
Okay. Do you guys remember what a z-score is?
Yeah.
What is a z-score? Yeah, it's how many standard deviations we are from the mean. Okay? So think back to z-scores. A z-score is the number of standard deviations we are from the mean. Okay. Now, today I showed you two symbols for the mean and standard deviation. What is the symbol we use for mean? Do you guys remember?
X
It's
bar.
called mu, and it looks like
I
this.
don't know mu.
And what was the symbol we used for standard deviation?
Oh, it's like a circle.
Okay.
Like that.
Yeah, it looks like that. It's like a lasso or something. Okay, a 6 that fell over. And so to figure out our z-score, we say z is equal to what? X minus the mean. So it used to be x bar, but now it's going to be mu divided by
Over the sigma.
over sigma. Okay? Alright. It's still x minus the mean over sigma. Again, this tells you, this part on top gives you how far you are from the mean. Dividing by sigma tells you how many standard deviations you are from the mean. Okay? So we're good, right? Okay, so we said something like, I don't know, I said, I completely forgot, but let's say we're dealing with horses now, okay? And let's say horses have a mean weight. What's an average weight of a horse? Let's say 1,200 pounds. Okay?
1,200 pounds.
I don't know, I'm making something up.
Okay.
Alright. The horses I'm talking about, they have an average weight of 1,200 pounds, okay? Whatever they are, alright?
Whatever they look like.
Let me tell you that.
And puppies have, no. Okay, and let's say the standard deviation for a horse, let's say, is 80 pounds, okay? So some horses weigh more, some horses weigh less, okay? What if I asked you, and let's say the weight of horses follow a normal model, or normal distribution. I might ask a question like, what proportion of horses weigh less than 1,250 pounds? Well, here, let's start off with an easier question. If I told you horses follow a normal distribution with a mean of 1,200 pounds, okay, just think of this answer, don't shout it out. What proportion of horses would weigh less than 1,200 pounds? Think of your answer. What proportion of horses weigh less than, okay, and the first one we'll write 1,200 pounds, okay? And this is the easy question. Okay, what's our answer? 0.5, right? That's the middle weight, that's the mean. So half of the horses weigh less than that, half of the horses weigh more than that, okay? The median is actually the middle, but because it's symmetric, the answer here is 0.5, right? So right here at 1,200 is right in the middle, and everything to the left is there. Is that okay? What is the z-score of a horse that's 1,200 pounds? Don't shout it out. Think of the answer. It shouldn't take you very long to figure it out. Okay? What's the z-score of a horse that weighs 1,200 pounds? Go ahead and tell me the answer. 0. A horse that weighs 1,200 pounds is at the mean. The z-score, how far is it from the mean? 0 standard deviations away. Okay? So 1,200 pounds is equivalent to asking what's the probability that our z is less than or equal to 0, okay, or x when we were looking at the table. Okay. So now I'm going to change it up. What proportion of horses weigh less than, let's say, 1,280 pounds? Okay. What proportion of horses weigh less than 1,280 pounds? Can we answer this question? If we know that the mean is 1,200 and the standard deviation is 80? Okay. Alright, so in this picture, what weight goes right in the middle? 1,200. And I'm above or below 1,200? Or am I drawing my line? I'm above 1,200 at 1,280. Okay. If a horse, or if the weight is 1,280, what is the z-score that corresponds to 1,280? No, what's the z-score? How many standard deviations am I from the mean? 1. I'm 1 standard deviation of the mean because my standard deviation is 80. My standard deviation is 80, so my z-score is 1. Okay, so here, z equals 1. If you're not convinced, you can do 1,280 minus the mean, 1,200, divided by 80, and you would get 1. Okay. So now I have a z-score of 1. When I have a z-score, I can look it up on my normal table, okay? And you'll actually see in the little text at the top, it says cumulative probability for z, okay? So it says you can look up the z, or actually in the top left-hand corner it says z. So what is the area to the left when z equals 1?
Oh.
0.8413. Okay? And that's the answer to my question. What proportion of horses weigh less than 1,280 pounds? 0.8413. Yes?
Kind of off.
It turned off?
No, it shows half.
Okay, you can fix it. Weigh less than 1,280 pounds. Okay. Okay. Question in the back. 0.8413. So what I have is now z equals 1. Okay.
Right.
What I'm doing is I'm looking at my table for what's the area to the left of z equals 1.
0.8413.
0.8413. Okay.
As long as the median is 0.
Here
No, sorry.
we've adjusted for it by using the z-score.
Gotcha.
Yeah. Yeah.
Does the 0.8413 mean percentage of horses that weigh less than 1280?
Yes. So 84.13% of horses weigh less than 1,280 pounds if they have this mean and standard deviation. Is that okay? All right. So let's try another example. Still keep horses with a mean of 1,200 and standard deviation of 80 pounds. Answer me this. What percentage of horses weigh less than 1,150 pounds? What percentage of horses, or what proportion, it's the same question, right? What proportion of horses weigh less than 1,150 pounds? Okay. Don't shout out the answer, but take a moment to figure this out. You're gonna have to do some rounding to look things up in the table. So here's a tip. This is the only time I recommend rounding to 2 digits, only for z-scores.
Because we're only dealing with this chart.
Because you're dealing with this chart, exactly. Okay, I'm going to put the answer up, and then we'll talk about how we got this. Or do you guys need another minute?
Yes, please.
Okay. Just want to make sure we're moving along at a swift enough pace that we can get all the stuff we need for the midterm. Okay. My answer is 0.2643. Is that what we got? Okay. So what does, if I were to draw a picture, what is the weight that goes right here in the middle? 1,200 pounds. Where am I drawing my line to cut off, separate that I'm looking for? To the left at 1150. And I want to know how much is shaded to the left.
Mm-hmm.
Okay? So, what is the z-score that corresponds to 1150?
Negative 0.265.
Yeah, so z is 1150 minus 1200 over 80, and I get negative 0.625, right?
Right.
Now, because we're dealing with this table, we have to deal with 2 digits. So I round this to what? Negative 0.63. Remember your rounding rules. So when I look up z equals negative 0.63, what is the area that it gives me? 0.2643. Is that okay? All right. This should be a quick answer. You might need your calculator, but it should be a quick answer. Don't shout it out. what if I changed my question to what proportion of horses weigh more than 1150?
Huh.
What proportion of horses weigh more than 1150? What would my answer then be? Okay, go ahead and tell me.
0.7357. Yeah.
0.7357. Now, how did I get 0.7357?
You can either subtract from 1.
I would subtract from 1. I've got my previous answer told me I had 0.2643 to the left of 1150. Now I'm looking for everything to the right of 1150. Okay? If everything adds up to 1, basically this number, whatever's over here and whatever's over here has to add up to 1. So I got 0.2643 over here. How much do I have over here? Subtract it from 1, I've got gives me 0.7357. Okay?
Yeah.
Are we good with that?
Yes.
Good. Okay. Okay, let's flip things around.
Raise your hand.
This time, okay, still assume horses have a mean of 1200 and a standard deviation of 80. I'm going to say, how heavy is a horse that is in the 80th percentile? Okay, what does it mean to be in the 80th percentile? You guys remember? 80th percentile means what percentage weight less than this thing?
20?
No.
No.
80%. Okay, 80th percentile means 80% have numbers that are smaller. Right? That was 80 percentile. So I'm basically asking what is the weight that gives me 80% to the left, right? So I'm saying, so I draw my picture again. What goes in the middle? 1200, my mean. And here, I've got some unknown weight that I don't know. How much do I have shaded to the left? 80%. Shaded to the left, I have 80%. What is the x that's going to give me 80%? That's what I want to know. Okay. So first off, the very first thing I have to do is I have to find the z that gives me 80%. So what is that z? Yeah, z equals, when z equals 0.84, the area to the left, is very close to 0.800.
It's 0.7995.
Okay. Is everyone okay with that?
No.
No? No? You're confused? Remember, just a few minutes ago we did these exercises. I said, tell me the x or whatever that's going to give me 80% to the left. Do you remember that? Yeah, kind of? Okay, that's all we're doing here. Okay, I'm saying, tell me what is the z or the x that gives me 80% to the left. Okay, when you look up and try to find the number that's closest to 80%, the number that you'll find is 0.7995, and that corresponds to what value? Z equals to 0.84.
Oh, got it.
Okay, great. All right, good. Well, I want to make sure everyone understands this. Okay. Okay. So far, so good. Yes. Okay. So we have a z-score now. How do I turn this z-score into a weight of a horse?
You subtract it by
Almost, but not quite. Okay. We're looking. So what I've got is a z-score, which tells me what is the z-score again? How many standard deviations
are we away
from the mean? Okay. So this tells me what? I'm 0.84 standard deviations from the mean. How big is a standard deviation?
80.
80 pounds. So that would put my weight, or not my weight, the horse's weight, where? 1260 something, right? Okay. Yeah, 1266. Okay, so Z is equal to x minus mu times, or divided by sigma, okay? So here I have 0.84 is equal to the x that I'm looking for minus the mean of 1200 divided by the standard deviation of 80. Okay? I multiply both sides by 80. Okay? Because I'm 0.84 standard deviations from the mean. Each standard deviation is 80 pounds. So this tells me I'm where? 60 what?
67.2.
67.2 pounds away from the mean, okay? If my mean is at 1,200 pounds, where does that take my x? Well, I add x 1,200 to both sides, and I have 67.2 plus 1,200 equals x. So x is 1267.2. How heavy is a horse that's in the 80th percentile? 1267.2 pounds. How does that feel? It's a few extra steps, but we can do it, right? Okay. Okay. All right, there's one more problem. I'm going to just walk you through the answer, okay? But please understand how to do this because you will see something similar next week, okay? Okay, so we'll still deal with our, is this okay that we're still doing this horses with 1,280 pounds and stuff? Or do you want something different? Huh? Different? Okay. Alright, so well, tell me something else that might follow a normal distribution. If we're not dealing with the weight of horses, we're dealing with...
Cats.
Huh? Okay, we'll say, maybe, I don't know, the height of, giraffes? I don't know, okay. Height, how big is a giraffe?
Very big. Like,
Alright. Height of a giraffe. 500 to 600 centimeters as an adult. Okay, so let's say
500.
the mean height of a giraffe, let's say, is 550 centimeters. It's in I don't have no idea what that is, okay? That's like 17 feet or something like that, okay? Let's ask Google, all right? 550 centimeters in feet. 18.044 feet. Okay, that's easier for me, okay? Alright, let's just say this is the case. 18 feet is our mean height of a giraffe. And let's say the standard deviation is 1.3 feet. Okay, I don't know, I'm just making this up. Alright, what if I asked what percentage of giraffes are between 17 feet and 20 feet tall? Yeah. Can we answer this? Okay, well, yes, I wouldn't ask you this question if we couldn't answer it. But I'll show you how to do this. Alright, does everyone understand what's going on?
Right.
Okay. Giraffes, I think, have the highest blood pressure of any mammal.
Wow.
Yeah. And they're scary, right? You don't
No,
wanna
they're
get-
cute.
Yeah, they're cute. Yeah, they got those little horns on their head and stuff.
They're really
I think
cute.
they're also the only mammal born with
They have
horns.
nice eyelashes.
You know how to giraffes.
Huh?
They have
You
nice
know about stuff
eyelashes.
about giraffes.
Okay. Now
You
you
ever
apparently
seen
didn't
them,
know their
like,
height though.
closer?
Alright,
They're
so
so cute.
in the center I've got 18. And what I'm asking for is if I draw a line at boundaries at 17 and 20. Okay? I want to know what is in
Oh.
between here and here. That's what I'm asking.
Okay.
Okay? So how can I figure this out? Well, it's a little bit tricky, okay? Well, not tricky. There's just a few extra steps. What I say is that first we're going to find out what percentage of giraffes weigh less than 20, not way less, are shorter than 20 feet, okay? I'm going to figure this out. That's going to be step one. Find the proportion less than 20 feet tall. Okay? And then, from there, I'm going to find out the proportion that's less than 17 feet tall. And I'm going to subtract off this chunk
From that.
from this entire piece. Okay? And when I do that, what I'm going to be left with is the space in between. Does that work?
Right.
Okay. So, very quickly, we'll work this through. Okay? Okay, so to get the proportion less than 20 feet, I gotta say z is equal, I gotta figure out my z-score, I do 20 minus 18 divided by 1.3. A giraffe that's 20 feet tall has a z-score of 1.54. Okay, what's your rounding? Alright. What's the proportion to the left of 1.54? That proportion, 0.9382. So the probability that z or x is less than 1.54 is equal to 0.94. Wait, 154? 9382. Okay. How much is less than 17 feet? Over here I write z equals 17 minus 18 divided by 1.3. And what do I have there? I have negative 0.77. Okay. How much? What's the probability of being less than negative 0.77? According to my z table, that takes me to 0.2206. Is everyone okay? Everyone's okay. Okay, so that says to the left of 20, I've got about 94%. And to the left of 17, I've got about 22%. So how much do I have in between?
You subtract.
So I take the difference. I take the difference, okay? So what's in between here is going to be 0.9382 minus 0.2206. Alright? And so that gives me 0.7176.
Is the percentage of giraffes between 17
You
and
always subtract,
Yeah.
right?
The percentage of giraffes that are between 17 and 20 feet tall, what percentage? 0.7176 or 71.76% is the area in between. Is that okay? Okay, so you've seen a few examples here, all right? If you need me to list them out. You've seen examples where I give you either a height or a weight or something, and I tell you what percentage, I ask what percentage is lower or higher than that particular value. You gotta know this for the midterm. Okay? You've seen another example where I said, this is the percentile, or this percentage is less than some number that we don't know. What is that number? Okay, that was, how heavy is a horse in the 80th percentile? Okay, you gotta know how to do that for the midterm also. Okay? And then here's one where I give you two weights, or a boundary, and I say how much is in between. Okay? You also have to know how to do this for the midterm. Okay? Yes?
Will we have questions like this in our homework?
Yes, you will have questions like this in your homework. Okay? And you should know how to do it for the midterm. Yes?
Related to homework, the day of the midterm, will we be assigned homework for the next week?
Yeah, no, there's no homework, so I will not be assigning homework next week on the midterm. There's no homework due in 2 weeks, okay? You have homework due next week. That's
What do
the.
you think we should study on?
Huh? What do you mean? So you have homework this week. You have homework this week, and you should study that for the midterm. But on the midterm, I'm not assigning new homework. Okay?
Oh, okay.
So for the week after midterm, there's no homework.
Exactly. In 2 weeks, there's no homework due. Okay, we've got about 15 minutes left, and we're going to go back to that very first thing that we did with the random variables, okay? I said, imagine if we flipped a coin 8 times, okay, and we said x is the number of heads that we see. This is, do you remember what I called it? Yeah, I said, what if we flipped a coin 8 times?
Binomial
And then I
distribution
said,
model.
x is the number of heads we see. Okay. And then, not question mark, that's a statement. And then I might say, and I asked, what is the probability that x equals 1, or something like that, or x equals 4, okay? Okay, what does it mean for x equals 4? Huh?
Is this the binomial distribution? Yeah.
It means I flipped the coin 8 times, and I saw 4 heads and how many tails?
4 tails.
4 heads and 4 tails, right? Because I flipped the coin 8 times total. So what is the probability that x equals 4? That means after 8 flips, I had 4 heads and also 4 tails. Okay? So this is a binomial problem. Binomial. The first thing that we have to be able to do with a binomial problem is identify 3 things, okay? All binomial problems will have an n, a p, and an x. Sometimes it will have multiple x's, okay? Okay, but it will always have an n and a p, okay? The n is the number of trials. In our situation, it's the number of times I flip the coin. Okay, so in our situation, our n is 8. Is that okay? The p is the probability of what we call a success for one trial. Okay, so in this case, success is an arbitrary word. Okay, or it's an arbitrary label, but it was what was used historically, and so that's what we still use today, okay? So in this case, seeing heads, because we said x is the number of heads we see, seeing heads would be a success. So for one coin flip, what's the probability I get heads? 0.5, okay? So P is the probability of success, again, an arbitrary label, And in that case, it's the probability of heads on one coin flip, which is 0.5. Okay. X is the specific number of successes that I'm looking for in my question. So in this case, when I say, what's the probability that x equals 4, the x that I'm looking for is 4. I'm looking for 4 heads, okay? X is the number of successes I want, okay? So in this case, 4. So I think the hardest part of the binomial is being able to identify a situation that's a binomial problem and then figuring out your NP and X, okay? Once you figure out NPX, everything else is easy because all you do is you use a table, okay? So a binomial is any time you repeat something multiple times. Every time you repeat it, either you could have a success or a failure, okay? Now, these are arbitrary labels. So it could be Chris Paul, okay, did he come back? Is he playing again? Not yet. Okay, he's injured for the Clippers, and anyway. All right, so Chris Paul is a basketball player, and he's very good at shooting free throws, okay? Let's say he's got a 90% free throw rate, okay? That means anytime he shoots a free throw, okay, tries to shoot a basket from the line, we'll say he makes 90% of them. Okay. So if I ask you a question, I say, Chris Paul has a 90% free throw rate, and let's say he shoots 6 free throws in a basketball game. What is the probability he makes 5 out of 6? This is a binomial situation. Okay? It's just like flipping a coin, except this time we're shooting baskets. In that situation, okay? Let me just write this on the board, okay? He's going to shoot the basket 6 times. The probability of making a basket anytime he shoots is 0.9. And I want to know what's the probability that he makes exactly 5 baskets that night. Okay? In that situation, what are my NP and X?
N is 6.
Shoots 6 free throws.
P is 0.9.
Okay. Probability of making it?
0.9.
Is 0.9. And what is the probability
What's the X?
he makes 5 baskets? Okay, so in this case, I got n equals 6, p equal to 0.9, and x equal to 5. Okay? Okay? Maybe we have a situation where I don't know, you go to you play a game and I don't know, you drop a marble in a thing and it could end up in 4 different baskets, okay? And let's say so by random chance it could end up in one of 4 baskets, okay? And let's say this is a lose, but you win in this one and you lose in that one, okay? So let's say you play the game 8 times. And you want to know what is the probability you win 3 times. Okay? Let's say we have an equal chance of ending up in any of these baskets. Okay? What is my N, P, and X?
N is 8.
N is 8. What's my P?
P is
Would it be 0.2?
Yeah, 1 out of 4, right? I could end up in any one of these 4 baskets. So the probability of winning, that's my success there, is going to be 0.25, 1 out of 4. And my X is 3. Is that okay? Okay, so I've given you 3 examples of binomial problems, and in each of these I have an N, a P, and an x. Okay? So to get our answers, I have to modify this one because
It has to be like 2.
yeah, it only shows up. I don't have 0.25 here. Okay, so let's say I've got a fifth basket here. Okay, so that would change this to 0.2. Okay, n is 8, p is 0.2, and x is 3. Is that okay? Okay. So the other paper I passed out is the binomial. Okay. And here you're going to look at the intersection of these three numbers, n, p, and x, okay? So the very first one, it's at the bottom of this page. The very leftmost number is the n, okay? So you go to find n is equal to 8, okay? And everything in this section, these are n equals 8. So you go to n equals 8, and then you go to p equals 0.5, okay? P equals 0.5, so that's right in the middle. And then we find the specific row with x equals 4. So n equals 8, p equals 0.5, and x equals 4. What is the intersection of those numbers? 0.273. Okay, is that okay?
So n is
No?
0.273.
No, this is my probability. The probability is equal to 0.273. Okay? Again, at the bottom of the table, it's going to say 8, and it's going to be 8, 0, 1, 2, 3, 4, 5, 6, 7. Okay? What you want, n equals 8. Go to the row, this is x equals 4, and you got to find the column that says 0.5. And right here, you go 0.273. Is that okay? Who's having trouble with the table? Okay. This is at the bottom of page A4. Okay, can you guys find n equals 8? Down here.
Yeah.
N equals 8. Okay. Across the top, can you find the column that says 0.5? Okay, so go all the way down 0.5, and you're going to see several numbers there. Okay, underneath n equals 8. You want to find the one that corresponds to the row that says x equals 4. Okay? And that number is 0.273.
Mine's 0 plus.
No, am I wrong?
No.
It's 0.273.
Yeah.
N equals 8, p is 0.5, and x is 4.
Sorry, I was looking at the wrong one.
Okay. You got to make sure you're looking at the right
I was
number.
looking at 0.0.
Okay. Let's try this one.
And 6.
Chris Paul shoots 6 free throws. The probability of making it is 0.9. We want to know what's the probability he's going to make 5. Right? So that means he made 5. How many did he miss?
1, 3, 5, 4.
He missed 1, right? He shot 6 baskets. If he makes 5, he missed 1. So what is 6, 5, 6 point...
3, 5, 4.
Yeah, so the probability here is 0.354.
No.
N is 6, P is 0.9, and X equals 5. Are we lost?
Yeah.
Okay,
Where do you find
all right.
9?
Behind your table. N equals
never
6.
mind.
Can you guys find that in the middle of the table?
I
N
never
equals 6.
got that.
Huh?
I never got that 9. I only got 1. Thank you.
You only got 1?
Oh my god, I got it.
Here's mine.
Thank you.
No, just do this.
I got it. I was looking at the wrong thing again.
Are we
It's on the top.
Are we still having trouble? This is most people this is the hard part, and then looking it up in the table is the easy part. Okay? I don't know what's going on. That's okay. All right. We'll get through this. Okay? N equals 6. Can we find it? Can we get 0.354? Yes. Okay. Thank you. All right. What about this one? 8, 0.2, and 3. What's the probability is 0.147. Is that okay? Okay, all right. Let's just make sure our understanding is good, okay? I'm going to do one more example. I know we're gonna be like 1 minute past 9:30, and I apologize. Well,
It's
okay.
okay.
All right. Let's say Chris Paul shoots 6 baskets again. All right, and his probability of making it. So same thing is 0.9. Okay. And I'm going to say, what is the probability he misses at least once?
Should it be the same answer?
He misses at least once.
Okay. Chris Paul shoots 6 baskets, and the probability of making it is 0.9. What is the probability he misses at least once?
You subtract 1 minus.
Okay, so the probability that he misses at least once means x equals what?
5. 6.
5 or 4 or 3 or 2 or 1 or 0, right? If he misses at least once, he could have made anywhere between 0 and 5 shots, right?
Add them all up.
So you would add up, there's a few ways we can do this, okay? This means x equals 0 or 1 or 2 or 3 or 4, okay? So one option is you take all of these numbers, and basically 0 plus means it's basically 0. It's not exactly 0, but it's practically 0. So you add up 0 plus 0, 0 plus 0 plus 0.001 and 0.015 and 0.098 and 0.354. Okay, you add these up and you should get you get 0.468. Okay, and it's because these two things actually add up to that last missing piece. Okay, so that's one way. Okay, because this is x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, and x equals 5. Okay, that's one way to do it. What did I say at least 1 is the complement of? None. So missing at least 1 is the complement of missing none, or making all 6, right? So what's the probability that he makes all 6? Probability that x equals 6, 0.531. Okay? So the probability he misses at least once is the complement of this, which is 1 minus 0.531, which gives me 0.469.
So that's like a shortcut pretty much.
It's like a shortcut, yeah? But it's the same thing also, okay? It's just different ways to get to the same answer, okay? All right, please make sure you understand this example as well. We have a question. 0.531 is n equals 6, p equals 0.9, and x equals 6. Okay? 0.531, this is n equals 6, p equals 0.9, and x equals 6. All right, we'll see you guys next week for the midterm. Good luck.
Bye.